I was wrong again. I said that in a glass that it's the same as a cylinder with a width 1/√3 way between the bottom and the top instead of halfway between. But it turns out that was wrong too. But then I came across a totally different approach. You see a cube with lengths A, and height of B, well, cuboid then, but with a cuboidal hole in the center of it with the same proportions, but just with a scale factor Y. It's made up of 6 of these shapes, like a square-based pyramid, but with the pointy bit cut off at the top. This will have a bottom width of A, a top width of AY and AY, and the height is this height B/2 minus this height BY/2, which is the same thing as this. And now we know that this shape, with a volume of A²B minus A²B y cubed for the hole in the middle, over 6 must be the volume of this shape. But we want to be able to figure out the volume of this shape based on the bottom width being A, the top width being big A, and the height being H. We don't know B yet. We can only know it once we get it in terms of what we do know, which is H. And since we know this is H, we can get B in terms of H, which will be 2H over 1 minus Y. And we don't know Y either, but since it's just a scale factor, it's big A over small a. And since this is the volume of one of these shapes, then in terms of A, big A, and H, which is what we're trying to figure out its volume based on, substituting the values in, we get this formula. And if you're wondering about the glass formula, that's just circular instead of square, but the same thing, so multiplied by pi/4. So anyway, that's how